Let's talk about a new era in robotics. Imagine a robot that doesn't just follow a command, but actually understands the idea behind it. We're right on the edge of this, where machines are moving past simple, pre-programmed instructions and starting to grasp the world in a way that feels, well, a lot more human. This is a massive leap forward for what we call embodied AI.
For years, robots have been fantastic at doing the same exact thing over and over in a factory. Very controlled, very specific jobs. But for a robot to be truly helpful in our messy, everyday world, it needs to understand concepts, not just code. And believe it or not, that's what's finally starting to happen.
So to really get a feel for what I'm talking about, check this out. One of Google's new robots was given this command: pick up the extinct animal. Now picture the scene. It's looking at a table with a bunch of little plastic toys on it, and one of them is a dinosaur. The robot was never, ever explicitly taught what an extinct animal is. And yet, it reaches out and picks up the dinosaur.
And that, right there, is the big question. How in the world does a robot connect an abstract idea like extinction to a physical toy and then actually do something about it? The answer is pretty incredible, and it lies in a totally new kind of AI model that finally brings together seeing, thinking, and doing.
That breakthrough is what's known as the Vision Language Action Model, or VLA for short. And honestly, it's a completely different way of thinking about robot intelligence. It's a real game changer.
So, what is a VLA? Exactly. The easiest way to think about it is like a single, unified brain for a robot. See, before this, you'd need separate AI systems, one for seeing, another for understanding language, and a third for controlling the motors. A VLA combines all of that into one seamless package. This isn't just a small improvement, it's a completely different architecture.
This table really lays it all out. On the left, you've got the old way, fragmented, clunky systems that were super brittle. You had to train them for every single little task. On the right, you see the new VLA approach. It's one unified model that can learn and adapt, pulling in knowledge from the internet. It's just so much more flexible.
Okay, so that all sounds great, but how does it actually work under the hood? Well, the core idea behind it is just brilliant. It's all about rethinking what a physical action even is.
So the researchers, they had this amazing insight. They thought, what if we stop treating robot movements as this totally separate, weird problem? What if, instead, we treated the robot's physical actions
just like they were words in a sentence? It sounds a little crazy, but they figured out how to basically translate actions, move your arm to these coordinates, or close your hand, into the same kind of text tokens that a language model uses. This means the robot's commands just become another part of the language it already understands.
And this is where the magic really happens. It's a two-step process. First, the model just soaks up the internet, learning about, everything, from what dinosaurs are to the concept of extinction. Then, in step 2, it's trained using data from actual robots moving in the real world. This is how it connects all that abstract internet knowledge to physical movement. It's literally learning to speak the language of action.
So, that's the tech. But what does it actually look like when you put it to work? Let's check out a fantastic real-world example of how this can be used to directly help people. It's a system called MARS.
MARS stands for Multi-Agent Robotic System, and this isn't just some abstract research project. No, this is a system designed from the ground up to help people with disabilities live more independently. This is where all that tech we've been talking about starts to have a really profound, life-changing impact.
Now, this diagram might look a little complicated at first, but the core idea is pretty cool. Instead of just one AI making all the decisions, Mars works like a team of specialized AI agents, all working together. They're in this constant loop. They perceive the world, they reason about it, they plan some actions, and then, and this is key, they evaluate that plan for safety. It's a non-stop cycle of trying to make smart, helpful, and safe decisions.
Let's just walk through that cycle real quick. It starts with perception. The robot looks around and figures out what's in the room. Then comes reasoning. It spots potential risks and figures out which ones are most important. After that, it moves to planning, creating a step-by-step guide for what it's going to do. And finally, you've got evaluation, where the robot basically double-checks its own work. If the plan isn't safe or efficient, it goes right back to the beginning and starts over.
And this table gives us a perfect example of what that reasoning looks like. The system doesn't just see a chair. It understands the context. So a chair that's kind of in the way but a wheelchair can still get by, that's a low-severity risk, priority 3. But a chair that's completely blocking the only way out? That's high severity, priority 1. The robot knows it needs to deal with that right away. That's real intelligence.
So this is all an incredibly exciting leap forward. But of course, it also brings up a whole new set of challenges. What does the road ahead actually look like for these super intelligent embodied machines?
We're definitely not at the finish line yet. There are some major hurdles we still have to clear. First and foremost, we have to ensure these robots are safe and unbiased. They need to get much better at handling situations they've never seen before. And maybe most importantly, we as a society need to have a really serious conversation about the ethics and impact of this kind of powerful technology.
And that really leaves us with this final massive question. These VLA models are giving robots the power to see, to reason, and to act in our world with a level of understanding we've never seen before. As this technology keeps getting better, it's not just going to change the robots, it's going to fundamentally change our world. The question we all have to think about is, how?